problems for homework on exact differential equation. So question is, determine which of the following differential equations are exact and hence solve them. That is, we have to determine these equations are differential equations are exact or not exact, and if it is exact, then find its solution. And we know that how we can determine the equation is exact or not exact. The equation is of this form: m dx plus n dy is equal to 0. Every equation, we have to reduce the equation. If it is not in the form m dx plus n dy is equal to 0, then it reduces to the form m dx plus n dy is equal to 0. And then find the da by m by da by y and da by n by da by x. That is, the coefficient of dx is m, the coefficient of dy is n, and we have to find the derivative of m with respect to y and n with respect to x. And if these two are equal, da by m by da by y is equal to da by n by da by x, then the given differential equation is exact differential equation. And then how we find the solution of exact differential equation? Then we use the formula integration m dx plus integration terms in n independent of x dy is equal to constant. So by using this formula, we can find the solution of the exact differential equation. So these are the 10 problems, and here these problems are also on the exact differential equation. That is, first find the general solution of this differential equation m dx plus n dy is equal to 0. So first show that da by m by da by y is equal to da by n by da by x, and then find the general solution by using the formula that integration m dx plus terms in integration terms in n independent of x dy is equal to constant, and that c constant is c. And then substitute this general condition y1 is equal to 3. Use this condition y1 is equal to 3. So what is the meaning of y1 is equal to 3? Means y is 3 if x is 1. And then at the in the final answer of this problem, that is the general solution of this problem, substitute y is equal to 3 and x is equal to 1, and find the value of that constant c. And then substitute that value in the general solution, that final answer of this problem. Substitute that value of c, which is obtained by using this condition. Then we have the particular solution. Okay, solution of this problem. So similarly, this problem, first find the general solution of this differential equation. Uh, Show first this differential equation is exact differential equation, then find its solution, and then use this condition, initial condition, in the final answer. That is, substitute y pi by 4 is equal to 0, means y is 0 if x is pi by 4. So substitute x is equal to pi by 4 and y is equal to 0 in the final answer of this problem, and find the value of c. And again, that substitute that value of c in the final answer of this problem, we get the required solution. So y0 is equal to 0 means y is 0 if x is 0, y0 is 1 means y is 1 if x is 0. That is, substitute y is equal to 1 and x is equal to 0 in the answer of this problem, and then find value of c and resubstitute that value of c in the general solution, we get the particular solution. Then uh, see this exercise. So these are also problems on the same type, that is, determine which of the following equations are exact. If it is exact, then solve them. So we have to determine whether these equations are exact. 15 problems. So in all these 10 and these 15, there are 25 problems of the type da by m by da by y is equal to da by n by da by x are not equal. So uh, these are also problems on the same type, but with initial condition y1 is equal to 3. That is, we have to find the general solution and then use this condition. So observe all these problem. If you observe last problem, y1 is equal to -1 means y is -1 and x is equal to 1. So find the final answer of this problem. Substitute y is equal to -1 and x is equal to 1, and find the value of c and resubstitute that value in the general solution. We get the particular solution of this problem. So in all, there are 25 plus this 5 and 5. In all, 30 to 35 problems are given in this exercise of the type exact differential equation. So we will solve some problem on this type, that is this is 10th number problem. Y sin x into y plus x y square cos x into y dx plus x sin x into y plus x y square cos x into y dy is equal to 0. And the question is determine whether this equation, differential equation, is exact. If yes, then find its solution. So what is the m? What is m? M is y sin x plus x y square cos x into y. That is the coefficient of dx, and this coefficient of dy is n. So they compare this equation with m dx plus n dy is equal to 0. We have m and n. And then dou by m by dou y, that is the derivative with respect to y. So y into sin x into y, derivative is u into v rule. So y means u, derivative of sin x into y is cos x into y. Derivative of sin x into y is cos x into y. Into derivative of x into y is x with respect to y. Derivative of x into y is x. And the derivative of x into y with respect to x is y. So the derivative of x into y with respect to y is x plus this v sin x into y, derivative of y is 1 with respect to y, plus this x is now constant quantity, and y square into cos x into y is the derivative by using u into v, but in bracket. So y square, and the derivative of cos x into y is minus sin x into y into derivative of x into y with respect to y is x, and plus v means cos x into y, derivative of y square is 2y. So after simplification, we have this answer, dou by m by dou y. Then dou by n by dou x. Again, the derivative of this quantity with respect to x. Now x into sin x into y, u into v rule. So x, sin x into y, derivative is cos x into y, into derivative of x into y with respect to x is y. X into y, derivative with respect to x is y. Then plus v means sin x into y, derivative of x is 1, plus now this y square is constant because derivative is with respect to x, means y square is constant, and x into cos x into y, u into v rule in bracket. So x cos x into y, derivative is minus sin x into y into derivative of x into y with respect to x is y, plus cos x into y, that is v, derivative of x is 1. So by using u into v rule, and then multiply this y square, and after simplification we have this answer. And if you observe dou by m by dou y is this, and dou by n by dou x is this, these two are not same, and therefore we say that dou by m by dou y is not equal to dou by n by dou x, and therefore the given differential equation is not exact. So this differential equation is not exact. So if it is exact, then we have to find the solution. The next problem is x y square sin x into y plus y cos x into y dx plus x square y sin x into y plus x cos x into y dy. Okay, so this is where to again we have to determine whether this differential equation is exact differential equation, and if yes, then we have to find its solution. So compare this equation with the differential equation, standard equation m dx plus n dy is equal to 0, right? E is equal to 0. Here is the mistake, right? E is equal to 0. So compare this equation with m dx plus n dy is equal to 0. We get m is this and n is this. Okay. Now we have to find dou by m by dou y. So the derivative is with respect to y, means this x is constant, and the derivative of y square into sin x into y is by using u into v rule. So y square sin x into y, derivative is cos x into y into x. Derivative of x into y with respect to y is x, plus sin x into y. Derivative of y square is 2y with respect to y, and then plus y into cos x into y, derivative is by using u into v rule. So y cos x into y, derivative is minus sin x into y into derivative of x into y with respect to y is x, plus v means cos x into y, derivative of y is 1. So after multiplying with this with x, and after simplification, we have 2x into y sin x into y, and 2 minus x into y sin x into y. This is 2 times, this is 1 time. So 2 times minus 1 time becomes 1 time x into y sin x into y cos xy. So this is dou by m by dou y. Now dou by n by dou x, that is the derivative of this n with respect to x. Now this y is constant quantity, so take y as common, and then x square into sin x into y, derivative by using u into v rule. So x square, derivative of sin x into y with respect to x is cos x into y into y, plus sin x into y, that is v, derivative of x square is 2x, plus This is right here plus sign, here is plus sign, so right here plus sign. So plus x into cos x into y, derivative is by using u into v rule. So right plus derivative x and derivative cos x into y is minus sin x into y into derivative of x into y is y with respect to x, plus v means cos x into y. Derivative of x is what? Derivative of x is 1. So we have this. So right here plus sign, here is the mistake. Write plus sign because it is plus x into, and then after simplification that is multiplied by y, and we have this answer 2x into y sin x into y minus x into y sin x into y, both the terms are same. This is 2 times, this is minus 1 time, so it has become plus 1 time. And then if you observe dA by m by dA by y is this, and dA by n by dA by x is this, and these two are same. DA by m by dA by y is equal to dA by n by dA by x, and therefore this equation, given differential equation, is exact differential equation. It's exact differential equation. Therefore the given differential equation is exact, and so its solution is, so this is the formula to obtain the solution of exact differential equation. Integration m dx plus integration terms in n independent of x dy is equal to constant c. So what is m? M is this x y square sin x into y plus y cos x into y, right? That dx plus terms in n independent of x. So there are two terms in n. This is the first term and this is the second term. What is that? X square y sin x into y, and the another term is plus x into cos xy. Here is plus sign. So these are the two terms, but both the terms depends on n. This term is depend not n, x. So this term is depend on x, or contains x. This term is also depend on x. So there is no term in n independent of x. So write 0 dy is equal to constant. And so this is the integration. Dx means integration is with respect to x. So y square is constant, integration x into sin x into y dx, plus again this y is constant, integration of cos x into y dx is equal to constant. Now here x into sin x into y integration is by using part rule. And so this x is algebraic function, sin x into y is trigonometric function. And what is the sequence of the function? It's LIATEE. This is the sequence: logarithmic, inverse, algebraic, trigonometric, exponential. So this x is algebraic function, and this sin x into y is a trigonometric function. So x is first function, sin x into y is the second function. And so the part rule is this: integration of first into second dx is what? First integration of second minus integration of second into derivative of first dx plus constant of integration. Okay, so right, use this rule. First integration of second cos x into y, so not cos, sin x into y. So what is the integration of sin x? Integration of sin x is minus cos x, and this is sin yx. Actually x into y means sin yx. Y is constant. So what is the integration of sin 4x? Is minus cos 4x divided by 4. Like that, integration of sin yx is what? Minus cos yx divided by y. So y is constant. Okay, so like that, sin 4x, if there is sin 4x, then integration is minus cos 4x divided by 4. So here is the sin yx, so integration is minus cos yx divided by y. Y is constant quantity. First integration of second, this is the integration of second minus this integration sign, and write integration of second. So write this quantity again, integration of second minus cos xy divided by y into derivative of first. D first means what? Derivative of first. So derivative of x is 1 dx plus this y, integration of cos x into y. Integration of cos x is sin x plus sin x. Integration of cos x is plus sin x, and integration of cos 4x is what? Sin 4x divided by 4. This is cos yx. So integration is sin yx divided by y. Y is constant quantity, is equal to constant c, integration constant of integration. So simplify this, multiply this y square, remain as it is, x this minus x cos xy divided by y plus now this minus and minus become plus 1 by y, integration cos x into y. This one y is constant quantity, so take out it outside the integration, so 1 by y, and this minus minus become plus cos x into y dx plus y get cancelled, sin x into y is equal to constant. And then write just integration of cos x into y with respect to x is what? This is again cos yx. So integration sin yx divided by y. So plus this remaining quantities. Integration of cos x plus b is what? Sin x plus b divided by a. So integration of sin x plus b is minus cos x plus b divided by. It is the rule here. So here the rule is cos x into y. That is cos yx, and y is now constant like a, b 0. So we have, by using this rule, sin yx divided by y, or sin xy divided by y, and then multiply by this y square in bracket. We have this y square get cancelled. So sin x into y plus sin x into y become 2 times sin x into y, and minus x into y cos x into y plus 2 times sin x into y is equal to constant. And this is the general solution of the given differential equation. So if suppose we are given here the condition, we are given the condition, suppose like this condition, like this problem, the initial value problem. Suppose y0 is equal to 1 or y1 is equal to minus 1 is the given condition here. Then how we can find the answer of this problem? So the condition is given, suppose y1 is equal to minus 1 or y1 is equal to 0. Suppose condition is y1 is equal to 0. Then what is the procedure? Obtain this solution, and then suppose the condition is given that y1 is equal to 0. y1 is equal to 0 means what? Y is 0 if x is 1. Then substitute y as 0 and x as 1 in this problem and find the value of c, and substitute that value of c again here. We have the answer of the particular solution of the given problem. So if the initial condition is given, first find the general solution. And then substitute the initial condition. That is, the substitute the values of y and x by using the initial condition. Suppose the initial condition is y0 is equal to 0, means y is 0 and x is 0. So substitute y is 0 and x is 0. We have the answer. And so if you substitute x is 0 and y is 0, then we have the answer. C of answer is 0, and then we substitute 0 as the answer. So minus xy cos x into y plus 2 sin x into y is equal to 0. This is the particular solution, not general solution. General solution of the particular solution of the given differential equation. So in order to find the particular solution, if the initial condition is given, then find first general solution of the given differential equation, and then substitute that constant value, find the constant value of constant and substitute that constant in the equation of general solution of this equation, and we have the particular solution. Next problem is next type of problem. So solve remaining problems. Solve all these remaining problems of this type. So same method. First write m and n, and then find dava m by dava y and dava n by dava x. Both are same. Then find the general solution of the given differential equation by using this formula. What is the formula? This is the formula to obtain the general solution. So there are the 25 to 30 problems to solve on the type exact differential equation. Already in the previous 2 lectures, we have seen that how we can find the solution of the exact differential equation, how we can identify or determine the given differential equation is exact differential equation. That is the necessary and sufficient condition for the differential equation of the type m dx plus n dy is equal to 0 is to be exact, is that dava m by dava y is equal to dava n by dava x. So solve all the problems of exact differential equation. This topic is important as far as the exam concerned. So if you are given the problem in this form m dx plus n dy, in order to determine the given differential equation is exact or not exact, just find dava m by dava y, write m and n, then find dava m by dava y and dava n by dava x. If these two both are same, then we say the given differential equation is exact. And if these two are not same, then we say that the given differential equation is not exact differential equation. And if the given differential equation is exact, then how we can find its solution? We use this formula, integration m dx plus integration terms in n independent of x dy is equal to constant. So by using this formula, we can find the general solution of the given differential equation, exact differential equation. Don't use this formula to another problem. If the differential equation is exact, then we have to use this formula, because the previous topics, what are the previous topics? The first topic is variable separable form, and its subtype is reducible to variable separable form. This is the first type. The second type is homogeneous differential equation, and its subtype is reducible to homogeneous differential equation. That is the also called non-homogeneous differential equation. The differential equation of the form dy by dx is equal to a1x plus b1y plus c1 divided by a2x plus b2y plus c2. This is the non-homogeneous differential equation, or differential equation reducible to homogeneous differential equation. That is the second type. And this is the third type, that is the exact differential equation. So this is the third type, and the next type is what? The differential equation reducible to exact differential equation. So solve first all the problems of exact differential equation, and then we will start the second topic, that next topic, that differential equation reducible to exact differential equation, or integrating factor. So uh, in the next lecture we will see this definition of harmonic function, and we will solve these type problems, that is find all m and n, that is the given differential equation exact. So this 3 and 4 type problem, and this is the harmonic function. So we will see these problems in the next lecture.